Okay. Okay, so let me present to you the module on sensor system and an application. Let me show to you the module specification sheet. We'll go through it together. So I think can you see the module specification sheet?
Yes.
Yes.
Okay, good. If it is visible to everyone. So the module is sensor systems and application. In my presentation to this module before, you have chosen, I think I've already given most of the details, but for those who have not seen my video on the presentation of this module. So this module is about Internet of Things. It's about sensors. It's about the different applications of IoT. Basically, it is your IoT module, but we have not explicitly called it IoT. We are calling it sensor systems and applications. So it is about Internet of Things. At the end of the day, this is becoming increasingly a popular all around the world. Okay, where we distribute, where we deploy sensors in the environment to monitor a different sort of data, whether it is environmental data, agricultural data, and it is increasingly being used. This is why in your applied computing degree, we have included a modules on sensor system and application. You see the aim here basically is to introduce to you the most important principles of Internet of Things and sensor systems. It will help you to develop and understand additional complexity introduced by the mobility. Energy is an issue, and know that it is not that you will limit ourselves only to setting up of a sensor and transmission of data. More than this, so in this module, you will learn about the underlying architectures. You will learn about the standards and the protocols that are used in IoT, basically in sensor system for data transmission, for capturing of this data and transmitting it eventually to the cloud. So we will study the different protocols. You will see there are a number of protocols that you will learn in this module. So this module is divided into two parts: the sensor systems, where you learn how to build such a system, the Internet of Things. And a second part of this module, we will see its applications, where it is applied. We will take real case studies where systems have been applied in agriculture, in environment monitoring, for road traffic monitoring. So I have chosen a number of application areas, including precision agriculture, healthcare, environmental, security, and surveillance. So these are some application areas that we are going to discuss. So at the end of the day, after completing this module, you should become proficient in Internet of Things, in sensor system, learning all the in and out, how to deploy, how to mount a sensor systems, and start monitoring and transmission of the data. So this is the outline syllabus. You'll see a number of it is on data aggregation, communication protocols. So these will be discussed in the module. Okay, so let me continue with the module information sheet. So I think you're able to see it. So the different learning outcome I've just mentioned about it. I will be a module coordinator as well for this module, the lecturer and module coordinator. Yeah, very important. So our lecture is scheduled, okay, it says 8:30 to 10:30. Actually, myself, I thought that it was 8:30 to 10:30, but actually, as per your module timetable, I say that it is 10:30 to 12:30, and it will be basically on online. Okay, and then lab on Thursdays, two groups. I think your coordinator has already told you about group A and group B. Okay, so 8:30 to 10:30, then 10:30 to 12:30. Note that this week we will not have any lab. Most probably I will inform you next week for the lab, because I need to get ready all the necessary equipment and everything. So no lab for this week. Hopefully we'll start it next week. So in terms of the module map, so these are the different things that we will cover eventually. So today itself, we are introducing IoT and sensor system, the whole ecosystem. Then our next topic, so first 2 weeks, we are going to introduce the whole module. Then next will be on sensors and actuators. Next 2 weeks, week 3 and week 4. Okay. After covering the sensors and actuators, we are going to discuss about the different architectures. Some 3 weeks, because we have a number of those architectures and standards. Then we'll plan a test. Then eventually at the end, we will be going to discuss about access technologies. Okay, these are the protocols we use for communicating the data. Short distance communication, long distance communication will be discussed. And in first semester itself, you'll see after you that we are going to cover 2 parts: the technical part on the protocols, the architectures, and then application areas. By the end, we are going to discuss about a number of application areas. So for this semester, we have environmental sensor system and precision agriculture and animal tracking application. So we are going to study those 2 domains for application of sensor system. Then semester 2, so since it is a yearly module, will spend a number of weeks on the IoT protocols, the different protocols that are relevant for this module: MQTT, REST protocol, COAP, 6LoW wireless span. So these are important protocols that we are going to discuss at the beginning of next semester. We'll spend some time on data management in IoT, edge computing, fog computing. And again, we are going to take a number of application areas next semester, including health monitoring, industrial monitoring systems, transportation, and security. So these are the different topics that will be covered. You have a number of books on IoT. You have a number of books on IoT that you can browse through, but we won't be explicitly using in any book as such. Everything will be through my lectures and practicals. Some useful links. Assignment, yes. So a number of lab sheet will be given to you. So there will be 2 types of lab work if you want. Okay. One type of lab work will be to perform technology reviews. Since this topic may be new to you, and there are so many things happening in this area, I will give you some lab assignment, okay, where you need to conduct reviews on specific technologies. For example, one of the lab assignment that I will give you is identify top 10 microcontrollers that we have on the market. So this will help you to familiarize yourself with the kind of product, whether it is Arduino, Raspberry Pi, all these popular microcontrollers that are available currently on the market. It's the same thing for sensors, for IoT cloud platform, and anything. I'll give you some lab assignments to conduct that you will have eventually to submit, which will be marked for your assignment 1. Then assignment 2, you will have to develop in the second semester, not in the first semester. So your lab for the first semester will consist of 2 things. Those technology reviews that you have to prepare and submit. You will have around 5-6 technology reviews, and then you will have also some are requesting permission to join. Let me grant them. Okay, so you will have those technology reviews to perform, some 5 or 6. I will issue it on a weekly basis, and I will set deadline for you to submit it through Google Classroom. This is one. And second, concerning your lab, you will work with actual equipment. We will build circuit in the lab and try to do interesting things. So as you know how to manipulate, for example, and the microcontroller board that you'll be working with is Arduino. I've not chosen Raspberry Pi; it is quite more expensive. So I have a number of Arduino boards that are there in the lab, and I will try to make you do a number of things, controlling a few things, some lights, some motor, to turn a motor at a specific degree. So we will try to do those simple things in the lab. Well, we're actually experimenting with the different types, some sensors as well, temperature sensor and everything. You will already be experimenting with it in the lab. So then you will spend some 5-6 lab again on those equipment. So you'll have 5-6 lab on technology equipment, 5-6 lab on a real equipment. And as I've told you, the microcontroller that we are going to use is a Arduino. Okay, an Arduino board. I will introduce to you how to program an Arduino board. Okay, simple programming. How to program an Arduino board, how to download the program on an Arduino board and execute the program accordingly. So these things will be introduced to you in the lab in the first semester itself. Then in the second semester for assignment 2, second semester you will use the lab time mainly to implement a project, a mini project. I call it a mini project where you have to actually apply everything that you have learned in your first semester to build an IoT solution. And during the first semester, you will have to decide, form your group, decide. I will issue the assignment anyway and give you the proper instruction about it. But it will be a group work where you will have to come up with an idea, a project that you are going to implement in your second semester. Second semester, your lab time will go mainly for the implementation of your mini project. And you'll see I've associated some marks concerning the assignment 1 and assignment 2 accordingly. So you will notice for the assessment, the exam paper is 60% only, not 70%, but 60%. And then for the different assignment, you see here, test 1, obviously we'll have our traditional class test. Test 1, 10%, test 2, 10%. But for assignment 1, those technology reviews that you're going to do, so I'm associating some marks to it. And for the mini project, again, you have 10%. So in all, you have 40%. So quite a large a part of your continuous assessment is of the whole module is on continuous assessment, and it is 40%. So you need to be very well connected with the class test, with the different assignment and everything, if you are to get a good grade in this module. So be careful, stay connected, submit all your assignment, do all your labs, and work on your mini project. I'll give you instruction for the mini project as when it will be issued. Don't worry about it. These are some other information. Yeah, that's it. That is, I think, concerning overall presentation of this module. So I think most of you have already made your decision to do this module. It is a technical module, as I've already explained. You need to stay connected, so it is not so much theoretical. There are so many things to learn. There will be programming as well, because you will have to program a microcontroller, that is an Arduino board in my case. Once you know how to program a microcontroller, for example, Arduino, shifting to other microcontroller board will not be a problem, because you will have the experience to do it. Yeah, this is it. So it will have a high lab component in this module. So be careful, stay connected. And obviously the lectures are very important, because the main, for example, everything about the protocols, about the architectures and everything will be discussed in the online lecture. Okay, you can submit questions if you have during the lecture in the chat. In the chat board, I will try to address them as far as possible. Okay, so having said that, let me take questions if you have. You can unmute yourself and ask question. In general, concerning this module, the assignment, the mini project, and the content of this module, or what I've just explained to you, the module specification sheet. Anything you want to ask me before I start the content for week 1? Feel free. I'll give you a few seconds. Unmute yourself and ask your question. If you have any doubts about this module, about its content.
I have one question. Do
yes,
we
so
need
what's
to buy the IoT equipment for the projects?
Say it again. I've not got you.
The equipment we will need for the prototyping, do we need to buy it, or we will get it at university?
Okay, so good question. There will be a basic set of equipment that you will get. Okay, if you can work out your project with this basic set of equipment, it is okay. I will not expect you as such to buy, but I recall last year some student, they have gone on their own to add a few things to their mini project. this also you will have the freedom to do it, but it is not necessary. There will be a basic set of equipment that you will get, that you may use, and you can complete your mini project with the basic set of equipment. But you know, those sensors on AliExpress and anything, you will get it very, very cheap now. A few dollars, $3, $5, you get interesting sensors and everything. If you want to buy those, you can do so. But from my side, I will not ask you to add to buy anything. But I know there are some students in the final year project itself, they will want to add a few equipments, and some students on their own, they want to play around, they want to get experiment on a few sensors. They will be welcome to do so. Okay, so there is not a mandatory requirement that you will have to buy. The board and everything, you will get it. So with some basic sensors and everything, you will be getting it. I will introduce you to the what is called the Arduino kit. The Arduino kit. We have bought a number of Arduino kit. In the Arduino kit, there are so many things already in terms of capacitors, in terms of some switches, all the necessary like temperature sensors and everything. There are a number of things already there, and I think you can use the Arduino kit to do it. And you can search online where you will already see the list of things that we have in the Arduino kit. This will be made available to you in the lab. Okay.
Okay, thank you very much.
Yeah. Any other question?
Yes, if ever we want to procure the equipment for ourselves, is there a specific model that we have to purchase, or can we purchase any?
Okay, so first thing I will tell you, don't purchase anything at this point in time. Let us introduce the module. You will be getting to know about microcontrollers and everything during the first semester. I know that it takes time to order for the equipment to come and everything, but if ever you're buying something, keep it for slightly later, after we have already covered a few lab and everything. This is one. Second, in terms of a particular model or brand or whatever, it depends on your microcontroller. If you're sticking to Arduino, then you will have to buy Arduino compatible sensors, equipment, and everything. For example, if you're going for a Raspberry Pi, then you will have to buy other kind of sensors and everything. But as I have told you, in our case, we will be providing the Arduino board. So everything that is compatible with Arduino is fine. But some students that have, for example, if you already have a Raspberry Pi at home, or you have bought one for your final year project or whatever, then I will not restrict you. I will not tell you, no, you should be doing it only in Arduino, because it's about learning. You need to learn the most you can. So I want to restrict you as such. If you want to use other equipment, you already have it and you have experience on it, so feel free. So don't buy at this point in time. Let's wait for some time. You will get to know more about the different equipment. Then you may decide. Anyway, you will have to identify the project. You will have to identify your mini project, the title, the title. I will validate it as well. I will check whether it is okay. It is up to the level for a mini project. You will be able to do it and everything. I will validate it for each group. Then after this, I will advise you with respect to the equipment. Okay. Any one last question if you have? No. Okay. If not, let me move on now to week 1, lecture 4, week 1. Where is the lecture notes? Are you able to see my slide?
Yes.
Okay, good. Okay, so let's start with week 1. So the purpose of week 1 here of the lecture slide, of this lecture slide, I've already posted it in the Google Classroom, by the way. will be to introduce to you the whole ecosystem. I want to give you an idea what is expected from you, what you are going to learn in the whole module. So after completion of this lecture slide, you will get an idea about the different components of a sensor system, of an IoT system. You will appreciate that IoT system is not only about deploying a sensor, capturing data. It is a lot more than this. There are so many things, the underlying infrastructure, the protocols, that needs to be taken care of. So this is why I've tried in this first lecture to give you an idea about the whole ecosystem. I don't know how many of you have followed during confinement. We have had an internship program for some international students. It was open to University of Mauritius students as well, where I have presented what I've called the ecosystem, the IoT ecosystem. It is more or less in the same line, but with more details in this lecture slide here. Okay, so let me start with in general, the computing power has been increasing a lot. What has happened? So originally, big computers, we were having like mainframe computers, very big computers, which were powerful. Now the same power, you have it in your mobile phone that you carry in your pocket, for example. So the computers themselves, they have been shrinking in size. They are becoming smaller and smaller. They have becoming more powerful. Okay, and they are having more memory. You must be aware, as applied computing student, the Moore's law. Moore's law says over the history of computing, the number of transistors in a dense integrated circuit has doubled approximately every 2 years. That is basically every 2 years, the capacity of our computer in terms of processing a power has been doubling. Okay, and this has proved to be true. Why I'm saying all this? Because now with IoT, with the shrinking of your devices, they are becoming smaller and smaller. We have created what is called MEMS, micro electronics. Okay, electronics that can fit, that are very, very small, that you can deploy. It can fit in our everyday fabric itself. So there is an area itself called ubiquitous computing, where computing disappears in our everyday things. So the electronics, it can be in a cup of tea. Just below your cup, you have a computer that is monitoring the temperature or whatever. So computing has becoming very powerful and very small. Miniaturization has happened. So this has given rise to what is known as the cyber-physical social data. So this is you have different access there. So since we are deploying more and more of those sensors in our everyday environment, so practically you can monitor anything at any place at any time. You can see it. This cyber means virtual. That is computer world, if we put it this way. Physical is the real world. So this cyber physical, it is being merged. That is virtual and physical, they are being merged, they are becoming one. They are not dissociated. Previously, world of computer, you need to switch on your computer in order to be able to work on your computer, to type a letter, to do anything. And the physical world, they were very separated. Now, no. The cyber and the physical, I don't know whether you have heard about augmented reality, where the cyber and the physical, they are merged. But there is a third dimension there. So cyber is your computer world, physical is our real world, our chairs, our tables, and everything. But there is a third dimension which is called social. That is in our everyday life. Social means our everyday life. Okay, we deploy sensors to monitor different things in our everyday life. You'll see the different issues that we have. We have large volume of data. At the top you see here, there is large volume of data that is generated, the necessary networking that should be there, the societal economic impact, the services and the application that are provided, and very important issue about security, trust, privacy that this is giving rise. So in this module, you will see you're introduced to all those aspects of this cyber physical social data. Let me proceed. Okay. So I've just told you sensor devices are becoming widely available now. It is being integrated in our everyday fabrics. whether for fitness applications, whether for health application, we want to monitor our body temperature, our blood pressure, about our sugar level in the body. So we are having sensors now that we can place on ourselves. It is already there on our mobile phone, monitoring, for example, our steps, the number of steps. For example, I have on my mobile phone an application that counts the steps that I'm doing per day. So this is again due to sensors that have integrated in our mobile phones and in our environment in general. So we are having more and more of those what is called programmable devices that you can program to do something interesting for you. And those sensors, they have become very small and can be integrated in practically everything. This is what has given rise to to Internet of Things in general. Let me proceed. Okay, so we are having more things are being connected now. Okay, so this has happened for some time now. Previously, let me do something. So previously, we were having only computers connected on the internet, for example. Now you have practically your everyday things are being connected to the internet. Can you still see my slide? I'm trying to put it on.
Yes.
Yes.
Okay. Okay, yeah. Now we're starting having even our everyday fabric, our everyday things being connected to the internet. This is from where we have got this idea of internet of things. It comes from the idea that we are not only connecting our laptop, our computers to the internet, but we are also connecting, for example, our refrigerator to the internet. We are connecting our house to the internet. Your surveillance cameras, for example, that you put to monitor your house, it is connected to the internet, so as you're able to see what is happening in your house, even when you are in another country, for example. You may be checking what is happening in your house because your surveillance cameras are connected to the internet. Your refrigerator is connected to the internet, so as you know what you have in the refrigerator, what you don't have. Your washing machine may be connected to the internet, so as it download a new washing cycle, for example. So everyday things are being connected to the internet. You have your body, you have an apparatus that is monitoring your body pressure, for example, your blood pressure. So this is connected to the internet, so as your doctor can do your follow-up in the real time. So there are many case studies like this now, where you have devices increasingly being connected to the internet. So not only things, so people connecting to things now. A person now is not having only one device, they're having many devices for monitoring for example, in this diagram, you see here, motion, different types of motion sensors, a ECG sensor for heart rate or whatever. This is transmitted through a device to the internet, and the doctor is able to do real-time follow-up on the patients. This is just a case where you see people connecting to things, and increasingly this is happening, and things connecting to things. So I don't know whether you are aware, there is an area called M2M. So a machine to machine connection. Previously it was many people to machine, we say HCI, human computer interaction. This is human to machine, but now we are increasingly having M2M. M2M means machine to machine, a machine connecting to another machine to do something interesting for you. Your car is connected to some network for music or whatever, and it is downloading a specific music for you. This is, for example, machine to machine connection, and this is increasingly becoming popular. So this is called things connecting to things. And this has given rise to a new whole area, which is called wireless sensor network. That is when you interconnect all those things together, you get a wireless sensor networks, where you need to find ways to transmit the data. So each sensor will not be able to transmit the data to the internet. So what do we have basically in a wireless sensor network? You have your sensors, you see on this side here. those sensors. They transmit the data in a multi-hop fashion in each other, and eventually this goes to some sync node. This is a sync node to some gateway. The gateway transmits the information to the internet, and then it goes on the cloud somewhere where you can check what is happening with respect to those sensors. This is a typical IoT network. Also will be this way. You'll have your sensing pod, you have the gateway pod, you have your cloud a cloud pod. As we proceed, you will see those three components in an IoT system.